Hi, Victor Morganti here from FactEngine. Today we're going to look at creating a relational knowledge graph from beginning to end using the Boston conceptual modeling software, and then we're going to query the knowledge graph using FactEngine. We've got Boston open in front of us, and in the Model Explorer we haven't got any models displayed at the moment. Let's create a new model. And I'll call that model Relational Knowledge Graph Cinema Bookings, and just some attribution. The model we're going to create today is a extrapolation of a model originally presented under the Active Facts project on GitHub by Data Constellation and Clifford Heath. There's one page in the model. We'll just delete that so we don't have any pages. So we've got a blank model in Boston. Let's now go to the model configuration, and we're going to set the database type of that to an SQLite database. We're going to create a knowledge graph using a property graph schema today, but we're going to do that over a relational database. Let's create a new database and call that Cinema Bookings. So we've just created a brand new database. We've got a connection string. We can test the connection. And what we're going to do today is we're going to create the database on the fly as we create our conceptual schema for our knowledge graph. So it's going to be synchronized with Boston, the database, and I'm going to hit OK on that. So let's add a new page to the model. We're going to add a property graph schema page. And we'll open that, and we can start creating our model. So we're going to create a database where people can make bookings to watch a film at a cinema. So let's drag a node type onto the page and call that node type cinema, and let's give cinema a cinema name. I'm going to make that text fixed length. We're going to say it's mandatory and give that 100 characters. So we can view the properties for our node type. We've got cinema ID and cinema name. So we've created a cinema. Let's set up a unique index on cinema name. So we've got a primary key on cinema ID, we've got a unique index on cinema name. Let's apply that. And of course we want to watch a film at our cinema. Let's give that a property. Let's say that's film name. So that's text fixed length. I'll say 200 characters for a film name. And let's put a unique index on film name. So we've got our cinema and we've got our films. Now of course we need people to go and watch those films. So let's create a node type person. And let's give the person a login name so they can log into the system and make their booking to watch a film at that cinema. Let's provide a unique index for login name. So we've got cinema, films and people. Now when the person logs into our system, we want them to be able to book a session at that cinema. So let's create a session node type. And we're going to say that a session is at a cinema, and a session is for a film. And what we're going to do on this particular node type, we're going to go to its properties, and at the moment it's got a reference mode of .id, which means it's got a unique ID of session ID. We're going to remove that, and now it's turned red because it hasn't got a primary reference scheme, so there's no unique way at the moment of referencing a session. We'll fix that in a moment. The first thing we're going to do is we're going to add a property date time, so we can make a booking to watch our film at the cinema at a particular date time in a session. And we're going to create a primary reference scheme across cinema ID, film ID and date time, so we can go and watch a film at a cinema at a particular date time, and that's a unique combination of all three that identifies a session, and where our database can have multiple cinemas and of course multiple films and multiple sessions on different dates and times. Now we're going to do something very special here. We're going to convert that to a fact type at the object role modeling level, and I'll explain that in a second. So we're going to say sure, we're sure about that. And the two edge types linked to session to film and session to cinema have gone dashed. That tells us that that relationship is actually part of the primary reference scheme, or the unique identifier for session. And we've successfully set up a session node type within our knowledge graph. Now a person's going to want to book a seat in a row in that cinema. So let's create a row node type. Let's give the rows a particular number. So a row has a row number, and a row is in a cinema. We're going to do the same thing we did with session with row. We're going to remove its unique identifier, and we're going to set up a primary uniqueness constraint across row number and cinema ID. So we can have cinema 1, row number 1, cinema 1, row number 2, cinema 2, row number 1, etc. So we've successfully set up row. Let's create a node type for seat. And each seat is going to have a letter, so we can sit in seat A in row number 1 in cinema 1. So we're going to create that property for seat. We're going to say that a seat is in a row. We're going to remove its unique identifier because we're going to create a compound reference scheme for seat, and we do that by setting up an index. So I'm going to set that to the primary reference scheme. So the unique way to identify a seat is by the cinema that it's in, the row that it's in, and the letter that it is. So it can be in cinema 1, row number 1, letter A, B, C, etc. So we'll apply that. We've successfully set up seat. Now of course we want to make bookings, so let's go ahead and create a booking node type. And where a booking is for a session and a booking is for a person, we're going to remove the booking ID as the unique identifier for booking, and we're going to set up a primary reference scheme for booking across cinema, film, date, time and person. So a booking is where a person books a session to watch a film that's at a cinema on a particular date time. So that's the unique identifier for a booking. We're going to apply that, and what we're going to do is we're going to convert that to a fact type as well. So now its dashed lines to session and person, the edge types are dashed because they form part of the primary reference scheme or the unique identifier for booking. And of course we want to make a booking for a seat. Now a booking can be for multiple seats, so let's convert that to a many-to-many relationship. And our knowledge graph is complete. There's a good reason why we converted session and booking to fact types, and we'll explore that now. If we click on session and go to the ORM reading editor, we can see that it has a reading, and it's just set to cinema has film has date time. We can change that to cinema is showing film at date time. We don't want to change the name of session, and we can say film is showing at cinema at date time, or we can say film on date time is showing at cinema. Now the reason why we would do that is because we can query our knowledge graph two ways. We can say which session is at a particular cinema and is for a particular film, or we can say which film is showing on a particular date time at a particular cinema. So changing this to a fact type allows us to do queries that we couldn't otherwise do against our knowledge graph. And similarly for booking, we can say session was booked by person, or we can say person booked session. So when we query our knowledge graph, we can say which person booked a session that is for a particular film at a particular cinema, because this is now a fact type at the object role model level. We have a relational knowledge graph because I can convert this page to an entity relationship diagram, and of course we're actually going to be operating over a relational database in this instance. So Boston caters for graph databases, well Neo4j as well, but the concept of a relational knowledge graph is that we don't care about our underlying database. What we care about is our schema, and where we have a entity relationship diagram view of our model, or a property graph schema of our model, or our relational knowledge graph, so that we can conceptualize our relational knowledge graph as either a graph database or a relational database, and query the database using SQL or graph queries. In the instance of FactEngine, we can query it with controlled natural language. So let's go back to our property graph schema and start setting up data. So we clicked on the cinema node type. We're going to have a look at its data. It hasn't got any data at the moment, so we're going to create cinema 1. Great Western Cinema, and save that. I'll just confirm that's committed. We're going to create a person in our database with a login name of Peter. Let's create a film. Let's put the film Rocky in there. Let's create a row in our cinema. So row number 1 in cinema number 1. We can have row number 2 in cinema number 1, etc. Let's create a seat in row number 1. So it's going to be seat with the letter A in row number 1 in cinema number 1. So we've created a person, a film, a cinema, a row and a seat. Let's create a session to watch Rocky. So the session is going to be in cinema number 1, the Great Western Cinema, the film number 1, which is Rocky, and we'll give that a date time, so the 1st of June 2022, and we've successfully created our session. Now let's create a booking. To watch Rocky at that particular session at that cinema. So cinema number 1, film number 1, which is Rocky, date, time, so we're going to watch it at the (10 AM), and for our person number 1, which is Peter, we'll just go and modify that session to make sure that it's at 10 AM as well. So that should be successfully saved. I'll just check that. Okay, and of course we want to book seats for that particular booking. So we'll view the table data for this particular edge type, where we're saying the booking that is for cinema 1, film 1, which is Rocky, on the 1st of the 6th 2022 at 10 AM. For Peter, we're going to book seat A in row 1 in the Great Western Cinema, and we've successfully created the data for our knowledge graph. So let's start querying our knowledge graph. So if we click on the model and open FactEngine, I've got some queries already prepared before us. So let's have a look at this first query. it says which seat has a booking that is for a session that is for the film Rocky that is showing on the 1st of the 6th 2022 at 10 AM at Cinema Great Western Cinema, and that seat is in which section. We'll take that out because we didn't create sections, and that booking is for which person. So if we execute that, we get a warning come back to say there is no fact type seat has booking. So it's gone to the virtual analyst and said there is only one fact type between the elements seat and booking. Would you like me to create a fact type reading seat has booking? We'll say yes, and we'll execute the query again. And it says there is no fact type film is showing on date time. Let's go back to our Property Graph Schema and go to the reading editor and create that reading. So film is showing on date time at cinema. And go back to FactEngine, and it's returned our row. So what we've done today is we've created a relational knowledge graph as a property graph schema. We've converted that property graph schema to an entity relationship diagram. Relational knowledge graphs allow you to view your database as either a property graph schema or a relational database, and we can write controlled natural language graph queries over our knowledge graph, and of course we can also write SQL over our database, because when your database is viewed as a relational knowledge graph, you get the choice of either graph queries or relational queries, because ultimately the data is conceptualized as either a relational schema or a property graph schema. Thank you very much for watching. I hope you enjoyed the video. If you like the video, please hit like and subscribe, and I'll see you in the next video.